So Slope is sort of like a man of mystery. He's like GoldenEye or 007 or Bond, James Bond. Has many identities but is all the same thing. Slope, one of Slope's identities is rate of change. Slope is the rate of change between any 2 points on a line. So if you look at the first point, point A, and point B, and you calculate the change, it's the rate of change between those 2 points. Slope is also rise over run. Rise over run is the change vertically over the change horizontally. So rise measures how much it goes up or down, and run measures how much it goes to the right. So vertical change is the rise. Up is positive. Down is negative. The run, horizontal change, is always to the right, and the right is positive. To the left, there's no change. This doesn't happen to the left because remember, my friend has walk rightotosis. He can only move from the left to the right. He can go up, which is a positive change. He can go down, which is a negative change. He can go horizontally, which is a slope of 0, and he can go vertically, which is undefined. I also wanted to point out that this rise over run is the change in y, so your y coordinate to y coordinate, over your change in x. This little triangle is known as a delta, and it means change. So this is, the rise is the change in your y coordinates over your change in your x coordinates. So delta y over delta x is the change in y over the change in x. And I'll show you some examples of that. If you take a look at the bottom corner here, where we have an actual example of our slope, you'll see that we have a line already drawn on our graph, and there are 2 points here. There's a point here, and it's really hard to see on the video, but this is at an x-coordinate of 2 and a y-coordinate of 1. And then we have another one that's at the x-coordinate of 6 and the y-coordinate of 3. So they're here to here. So what we do to figure out the rise over run, or the slope here, is we count the rise. So if you look at this here, you're going to see there's a rise of 1, 2. So it goes up 2. And notice that our line is going up, so we know it's going to be positive. Right away you want to look, is it positive, is it negative, is it 0, or is it undefined? We can see this is positive because Slope Dude would be walking up a hill. So this is positive, so we can go ahead and show that it's positive. Now we just need to count the rise over the run. So the rise here is 1, 2. So I'm going to go ahead and write my 2 there. And then my run is 1, 2, 3, 4. So I'm going to go ahead and write my 4 here. So right now I have a positive 2/4. Right now I have a positive 2/4. Now, whenever you have a fraction, you have to simplify. So you can go ahead, if you know this mentally, that's fine. Or you can go ahead on your calculator and you can do 2 ABC4, enter. And it's going to give you the actual answer, which is positive. We don't really have to write the plus sign there, though. 1/2. So the answer here for the slope is 1/2. All right, if you take a look at my non-examples over here, you're going to see that these graphs look different. Why do these graphs look different? They look different because they're curved. This curve here is known as a parabola, and a parabola happens when the line does not have a constant rate of change, and it is not a straight line. So we can only use slope, we can only find slope for straight lines. So in this box here, you're just going to write straight lines. Sorry, mine didn't quite fit. So anyhow, whenever you have a curved line of any kind, that you cannot find the slope of because it does not remain constant. These are, so far, the different identities of slope that we'll be working with. There are more that you'll find out about later.